This video is on finding volume by using the cross-section method and also the double integral method. And so here I have this solid that is bounded by this region R right here on the xy plane, and then above it, above region R, is the plane z equal to 10 minus x minus 2y. And so first I'm going to use the cross-section method and then use the double integral method. And so here's the plane z equal to 10 minus 2x minus y again. And so to find the point of intersection with the z-axis, we just set the x to 0 and set the y to 0, and we get z to be 10. And then the point of intersection on the x-axis here is to set the z to 0 and set the y to 0, and we get x to be 5. And for the y-axis, the intercept is going to be when we set the x to 0 and the z to 0, and we end up with a y of 10. So these are the three intercepts. And then this is the surface, and then this is the solid that we want to find the volume for. And so first I'm going to use the cross-section method. And so here's the cross-section at z equal to 1. This is z equal to 1. And then here's the cross-section at z equal to 3. And then here's the cross-section at z equal to 6. And now let's find the area of the triangle at the base here. This is on the xy plane, and this is when z is equal to 0. And so we let z be 0 and then solve for x, then we get x to be 10 minus y over 2. And if we solve for y, then we get y to be 10 minus 2x. And this is the base of the triangle, and this is the height of the triangle. And notice that this is a right triangle, and so the area be 1/2 the base times the height. And so here we can see that the base is 5, and then the height is 10. And so the area be 1/2 times 10 times 5, which is 25. And now let's find the area of this triangle when z is 1, and so this cross-section right here. And so when z is 1, then we get 1 equal to 10 minus 2x minus y. And then solve for x, we get x to be 9 minus y divided by 2. And solve for y, we get y to be 9 equal to y equal to 9 minus 2x. And so to get the base of the triangle, then we need the distance from here to here. And so we need this point. But notice that this segment right here is just directly above the x-axis. And therefore at this point, the x will be, the y will be 0. And so at this point where z is 1, and then the y will be 0. And so set y to 0, we get x to be 4.5. And so this point right here, x is 4.5, y is 0, and z is 1. And so the distance from this point to this point is the base. And therefore the base is 4.5. And then to get the height of the triangle, then we need this point right here. And then this segment right here is directly above the y-axis. And therefore at this point, the x will be 0. And so we set the x to be 0, then we get y to be 9. And so at this point, x is 0, y is 9, z is 1. And therefore the distance from here to here will be 9. And the area of the triangle will be 1/2 times 4.5 times 9, which is 20.25. And so for a given z, and then if we solve this equation right here for x, then we get x to be 10 minus z minus y dividing by 2. And then solving for y, we get y to be 10 minus z minus 2x. And to get the base of the triangle, of any triangle, any cross triangle, a triangular cross section here, the base is always going to be directly on top of the x-axis. So we set the y to 0. And so if we set the y to 0, then we get x to be 10 minus z minus 0 dividing by 2, or 5 minus 0.5 z. And similarly, to find the height of the triangle at a given z, we set the x to 0, since this side right here is directly above the y-axis. And so we set the x to 0, and we get y to be 10 minus z. So the area of a triangular cross-section at a given z would be 1/2 times 5 minus 0.5 z, which is the base, and then times 10 minus z, which is the height. And so to find the volume of this solid right here, what we're going to do is we can divide it into many slices. And so first, let's divide the interval from z equal to 0 up to z equal to 10 into z sub 0, z sub 1, z sub 2, z sub 3, all the way up to z sub n, which is 10. And then let z sub I be the distance from the origin here up to the ith slice. And then also let the thickness of the ith slice be delta z sub I. And therefore the volume of this ith slice will be the area of this triangle, and then times the thickness of this ith slice. And a few moments ago we found that for a given distance from the origin to the slice, the area of the ith slice will be 1/2 times 5 minus 0.5 z sub I times 10 minus z sub I. Once again, z sub I is the distance from the origin to the ith slice. And then the thickness of the ith slice, we'll call it delta z sub I. And if we have an infinite number of slices, then the volume of the solid will be written like this, with n running to infinity. And then just like before, if this limit here exists, and then we defined it as the integral from 0 to 10, 0 to 10. And then we get 1/2, 5 minus 0.5 z, 10 minus z, and then dz. And evaluating this integral right here, then we'll get 250 over 3, which is 83 1/3. And so that's the cross-section method. And so the volume of the solid is 83 1/3. And now let's use the double integral method, and then we'll see that we'll get the same answer. And now let's find the volume of this solid here using the double integral method. And so here we have region R, and the vertices are 0, 0, 0, and then 5, 0, 0, and then 0, 10, 0. And we can use either the dy dx method or the dx dy method. And so let's go ahead and use the dy dx method here. And so in this case, since we're doing dy dx, the bounds on the x will be constant. So it'll be from x equal to 0 to x equal to 5. And then the bounds on the y will be variable, And so it would be from this line, the line y equal to 0, to this line. And this is the line y equal to 10 minus 2x. Notice that the slope of this line right here is negative 2. And then the y-intercept is 10. And therefore the equation for this line right here is 10 minus 2x. And so here we have the outside integral will be from x equal to 0 to x equal to 5. And then the inside integral will be from y equal to 0 to the line y equal to 10 minus 2x. And then the height function, which is this plane right here, which is z equal to 10 minus 2x minus y. And so first, we'll go ahead and integrate the inside integral. So this is the inside integral. The 10 minus 2x will be constant since we're integrating with respect to y. So we get 10 minus 2x times y. And then the integral for y will be y squared over 2. And then we need to evaluate from y equal to 0 to y equal to 10 minus 2x. And so in the place of y here, if we put 10 minus 2x, and then simplify, we end up with 2x squared minus 20x plus 50. And so the volume of the solid here is going to be, we'll end up with this integral right here. So the inside integral is 2x squared minus 20x plus 50 here. And then if we evaluate this integral from x equal to 0 to x equal to 5, then we end up with 250 over 3, which is 83 1/3. And recorded a few moments ago when we used the cross-section method to find the volume of the solid, we also got 250 over 3. And that's the end of the video.